Hello wonderful person, this is Anton, and today we're going to be talking about some really groundbreaking research when it comes to levitation. And more specifically, as you can see in this video, the type of levitation that's never been done before. And although it might be kind of difficult to see what's happening here, I'm obviously going to explain exactly what's happening and how all of this works. But in a nutshell, what the scientists were able to create here is essentially levitation by using lasers. This relatively thin disk is levitating supported by lasers underneath, and all of this is done in relatively thin atmosphere, which actually creates an extremely important opportunity for some of the future missions to the upper atmosphere. It actually might allow us to finally find a way to place different objects in parts of the atmosphere where we've never been able to explore more thoroughly. But let's actually talk about levitation in general first, because this is a very wide topic. Mostly because levitation can be produced by different types of means. The most common type of levitation is probably the magnetic levitation, and it's also the one that's used the most on the planet. For example, if you ever go to China, one of the coolest things that they have in terms of transportation are the maglev trains. The magnetically levitated trains that are able to travel extremely fast and also allow for a relatively comfortable travel as well, because they don't really shake, they don't really move that much, and so you don't even feel like you're moving at all. But there are actually several other types of levitation, with most of them still being more theoretical without having any practical use in real life just yet. For example, a few years ago there was an experiment that was able to levitate frogs, and I think it was also mice as well, by essentially producing an extremely powerful magnetic field and forcing the water molecules inside the frogs and mice to turn into miniature magnets, thus allowing these animals to literally stay above the ground. Now unfortunately I couldn't really find the footage for this, but the mice in the experiment, from what I remember, only kind of panicked for the first few hours, and they actually adapted to living in this levitating condition after 4 hours. And surprisingly, there were absolutely no health effects whatsoever, and once the levitating part was over, they were able to return to their normal activities afterwards. And in this case, this is an example of so-called diamagnetic levitation. It's the levitation that's still magnetic in nature, but is actually created when the object is forced to become magnetic, even though it wasn't magnetic before. We also have examples of so-called acoustic levitation, and that's when you use the air waves, or basically the sound waves, to force an object to levitate in the middle of the air as well. But this is something that obviously still has no physical use as well. Or in other words, it's still very theoretical and experimental, but does not have a practical application yet. Then there is something called electrostatic levitation, which is a little bit different from the magnetic levitation, where here it's the static itself that causes an object to float. It's sort of similar to, for example, rubbing a balloon against your hair to give it a little bit of static, and then placing it between two objects that are charged in order for it to float in the middle. Then the obvious example here would also be aerodynamic levitation, which is basically when you force a lot of air pressure to cause the object to float above. There's also something known as quantum levitation, which normally relies on quantum effects, but this is a very complex topic, and it actually deserves its own video that's going to be coming out probably sometime in the future, which is also a very good time for me to mention that you might want to subscribe to the channel, because first of all, you'll be always notified when there's a stream coming up or something, and second of all, it obviously helps the channel grow. Anyway, even though there are actually a few more types of levitation that are worth mentioning, I think one of the most exciting types of levitation is what's known as the optical levitation. That's when you essentially use light, or in some sense photons or lasers, to cause the object to float in the air, either using the momentum from the photons or by some other means. And this is pretty much exactly what this paper is about. They found an extremely interesting, very functional, and actually kind of mind-blowing way to levitate an object using lasers. And in this case, we're talking about a relatively large object, something that can potentially be used in industries to, for example, launch something into certain parts of the atmosphere and thus explore those parts or use them in some way. Now actually, a quick side note, when it comes to the atmosphere of our planet, and also the part above the atmosphere, the open space, there are certain regions that we've been able to access and to use quite a lot, but certain regions are very difficult for us to access, even though they are important in, for example, predicting weather, or even doing a lot of other scientific studies. For example, this is probably the most used area, the troposphere, which is basically where the aircraft can still function and has obviously been used quite a lot in the last few decades. It allowed us to travel vast distances extremely quick by using different types of jet airplanes. Then above this, mostly in the exosphere, that's where we have a lot of satellites, And that's essentially the realm of space science. We've kind of found a really effective way to place a lot of objects there, and a lot of these different spacecrafts and satellites have essentially propelled us to a completely new age of information. But in between these two layers, in the Mesosphere specifically, at the altitudes of anywhere from 50 to 80 kilometers, that's essentially where we haven't really explored very much. We have no aircraft that can fly that high, and because those areas still have a little bit of atmosphere, satellites cannot survive there for a very long time either because they end up essentially crashing. So the combination of just a little bit of atmosphere to provide enough drag for satellites, but not enough atmosphere for airplanes to fly, creates this area in the atmosphere that's basically kind of like the dark unexplored area that scientists have been trying to reach for a long time. And it seems that levitation, and specifically optical levitation, might finally provide an extremely effective solution in helping us launch different types of probes and different types of satellites and objects in order for us to access that particular area. So let's talk about the study, what was done, and what exactly it discovered, which as always you can find in the description below, by the way. For this study, the scientists created this kind of a laser bed with the actual lasers positioned in this sort of shape, where each of the individual lasers could be controlled in terms of intensity in order to control the object that the scientists were trying to levitate. In other words, this allowed the scientists to move the object around. They then took these discs made out of mylar, which is that stuff that's often used to protect or insulate different materials, and is also that material that's often used in satellites or a lot of other NASA-related launches, where you can kind of see this golden sheet covering the surface. And then they took these relatively small mylar discs, turned one of the sides very thin and extremely reflective, and turned the other side into what they refer to as the structured surface. Essentially, it was very imperfect, it had a lot of different protrusions and filaments, and overall all of this resembled something like this. This is the smooth side, this is the other opposite structured side. And then they took these discs and placed them into their laser machine, which resulted in this. The discs were levitating. And then they lowered the atmospheric pressure inside this chamber, turning it into something equivalent to about 80 kilometers in altitude above planet Earth. And then, when they started the machine, this is what they observed. The discs started to levitate. And the levitation was entirely caused by the lasers because they could basically control the motion of these objects. Now, this is where things get interesting. Even though the assumption here initially was that it was probably caused by the thinness of the disk, and maybe this is actually caused by the photons themselves, or basically the pressure from the photons, which would be, by the way, very difficult to do with some of the larger objects, in reality what was happening here is that the lasers produced a completely different type of levitation, the aerodynamic levitation. Because of the difference in surfaces here, the surface with more structure in a sense ended up creating an overall motion of air molecules, forcing the object to create lift and to keep it above the surface. And so what we're seeing in this particular video that you're about to see is really the air pressure causing the object to float above. The levitation, even though it's produced by the lasers, is actually aerodynamic in nature. And that's of course both surprising and extremely encouraging, because this means that this particular technique can be applied to much larger objects and can potentially allow us to levitate very large probes or very large satellites in the area right above the point in the mesosphere. Or in other words, using this technology, we can technically place satellites or probes or different scientific missions into the location somewhere in the mesosphere and essentially control these objects using lasers on the ground. Now, that's something that we don't really know how to do just yet, but it's definitely something that's not beyond our capabilities as a species. As a matter of fact, in the last few years, scientists have already been investigating controlling things with lasers from the ground. And the findings from this particular experiment definitely give us a really good reason to actually try this, because for the first time we might actually finally have access to the mesosphere, that particular area of our atmosphere that's still kind of mysterious and that we don't really understand very well. But naturally, it will also probably take a few years before someone develops something practical out of this. It's a great discovery, very interesting, super exciting, but it will take time to develop this and it will take time to make this into something viable in the future. Either way though, definitely something to look forward to. But I guess until we learn something else, or until a new discovery that somehow relates to this, That's pretty much all I wanted to mention. Thank you so much for watching, subscribe if you still haven't, and if you'd like to support this channel, check out the channel memberships and possibly support this channel on Patreon or by buying the Wonderful Person t-shirt you can find in the description. Either way, I'll see you tomorrow, come back tomorrow to learn something else, and stay wonderful, and as always, bye bye.